Hey everyone, I'm Edward Ford, and whether you're thinking about buying a Shapeoko, you just bought a machine, or you're a master CNC user, this is the video for you. Today we're going to build this Bluetooth speaker from scratch with the Shapeoko. Every step of the process detailed. Let's get started. Let's run through all the parts you'll need to finish this build. We need a Bluetooth amplifier, hardware, rechargeable batteries, speakers, wiring harness, power supply, a 90-degree V-bit, a 1/4 inch end mill, volume control, Plastidip or regular spray paint, Shellac to seal the MDF. We chose maple, but any hardwood would do. Needs to be at least 12 inches by 5 inches by 3/4 of an inch thick. And MDF for the speaker body. This is 2 feet by 1 foot by 1 inch thick. We're going to learn how to draw these parts in Carbide Create. And if you're not familiar, Carbide Create is the 2.5D CAD CAM package that comes with all Shapeokos and all Nomads. You could draw this design in another program like SolidWorks or Inventor or Fusion and then import the DXF file if you wanted to, but this is a simple enough project. We're going to draw the whole thing natively in Carbide Create. So the first thing that we want to do in Carbide Create always is set up the job, and that's this icon in the top left. So we click that and we're going to set our stock sizes to match what our physical material is. And the MDF that we're using is 24 inches wide by 12 inches tall, and it is exactly 1 inch thick. We're going to set the Z0 position to the top of the material. So that's where we will actually zero the cutter. And the Toolpaths 0 is going to be the lower left-hand corner, which you can always tell on the screen where Toolpath 0 is by finding this red and white origin symbol. For the material, we're going to select MDF, and that's going to help us auto-calculate the feeds and speeds later. For this project, we're using a Shapeoko XL, and we're going to set the retract height to 3 millimeters, which is about 1/8 of an inch. The last thing we're going to do is change the grid spacing to 1/4 of an inch. And we're going to click OK, and now you can see the canvas updated. It's now the same size as our stock material. So this piece is the main body of the speaker. There are 4 MDF pieces, 3 of them are identical. So we're going to use one design to make all 3 pieces. The outside perimeter of the speaker is 11 inches wide by 3.7 inches tall. And we're making this a square, so this radius field doesn't matter. So we'll click OK there. And now we need to set up the holes around the hole pattern around the speaker body. So one of the things I like to do for that is draw a rectangle that we'll basically use as a construction line, which means that we'll delete it when we're done, but we're going to use these corners as references. So our reference square rectangle is the same as the hole pattern, which each hole is 0.394 inches from the edges. So if you subtract that value from the perimeter, we come up with a hole pattern of 10.212 inches wide and 2.912 inches tall. Click Apply. And now we can select both of these shapes and use the alignment tools to center align them. Now we're going to draw our circles, which this circle size will change depending on the part that we're making, but for the 3 MDF pieces in the middle, the radius for this circle is 0.13 inches. So we're going to need 4 of those, so I'm just going to highlight it and then Command C to duplicate it. then you can grab these circles in the center and snap them to the edges of our construction rectangle. The other way to do this would be to just figure out the XY coordinates of each hole and type those coordinates into this left-hand pane where you can specify the XY. We're not going to do that, so we can delete. And that's our main speaker body. So this rectangle is a construction rectangle, which means that we can delete it now because it's served its purpose. So the other feature on these three inside pieces is this center cutout. And the center cutout is 9.674 inches wide by 3.2 inches tall. Click OK. And now we can center align these two pieces, same as last time. And now we have the main design of pretty much the entire speaker. So we want to select all of these and group them together. And then we can move this around without risking moving any of the pieces. Now that we have the three pieces for the body made up, we're going to make up the back piece. And to do that, we're just going to copy these body pieces. And one thing you'll note here is when you copy something that's grouped, it actually doesn't keep the group. So the first thing I do when I copy or duplicate any sort of feature is click this button, which will regroup them. So now we can move this around without worrying about it blowing up. And we're actually going to do that a couple more times. So we'll copy it again, regroup it. Now we have our three speaker panels, the three main body panels, and we're going to duplicate it one more time to do the back, regroup those. So let's start out here and just rotate all of these pieces. I could have done this before I copied them, but then you wouldn't learn anything. So rotate that, just rotating all of these 90 degrees. And then they'll all fit on our stock material in a sensible and sane way. So one more, rotate, 90 degrees, apply. Okay, so we have plenty of room on the material. When we lay these out to actually cut them, we want to give ourselves a little bit of room, a little bit of margin on the left and the right. So looking at the grid here, we are about 1.5 inches off of the edge. That should be fine. I'm just going to do 1 inch for consistency. And we're splitting the difference vertically, so we've got a 1/2 inch on the bottom and a 1/2 inch on the top. So to be safe on the left to right spacing, I'm going to just do 1 inch between each one of these pieces. That'll give us plenty of room for the tool and for support tabs. So now that we have the body and the back designed, we need to add toolpaths. So we're going to click up into toolpath mode. And when you're in this mode, you can't edit. So none of these pieces will move around. They're all locked. And you should really start from the inside out. So we don't want to cut any of the profiles for these pieces before we cut the inside feature. So we'll start with these center panels. And these three panels, three main body panels, are the same. So we're going to select all three of those and then click Contour. And we're going to select our cutter. You can see here 201, the 1/4 inch cutter is selected on mine. If it's not selected on yours, click Edit. And then you've got this nice pull down menu with all of the cutters preloaded. So we'll select that. You'll notice at the bottom here, it sets the speeds and feeds automatically. And these are actually pretty good. They're conservative, but they will work. If you wanted to manually adjust them, you can uncheck this box. And I'm going to change the plunge rate from 12.5 inches per minute to something like 30 inches a minute. And then click OK. And you can see a summary of the speeds and feeds up here. So the cutting depth is how deep we actually want to cut this feature. And for these three center panels, we actually want to go full depth. So we're going to do use stock bottom. And I'm going to add 5 thou to that cut, which means it'll actually cut into your wasteboard, but you'll be sure to make it all the way through the material if there's any sort of variance. You could probably reduce this to 2 or 3 thou, but we'll do 5 thou to be safe. And then for the offset direction, we actually want to cut inside of this feature. So we're going to select the inside left feature, and you can see in the design, the blue line represents the center line of your cutter. So that is inside the feature we're trying to cut, so that's correct. And because we're cutting these pieces all the way out, I want to add tabs to prevent them from flying across your shop. So the tab width, I'm going to change this from 12 to 6 millimeters wide, and the tab height I'll leave at 3 millimeters. That's going to leave you a tab that's about 1/4 of an inch by 1/8 of an inch that we can pretty easily sand off when we're done. So once you get the dimensions set, you can click on the design, and where these squares with X's in them are placed, we will get a tab. Generally, you want to use 4 tabs for a rectangle or a square. That should give it enough support that it won't vibrate out. So we can click OK here, and I want to name this toolpath Inside Profiles, and then click OK. And if you want to see what it'll look like, you can come down here to the simulator, select MDF, and then click Show Simulation. And here you get a 3D rep of what that operation is actually going to do. So if we uncheck Show Toolpath, you can see at the bottom of these cuts, our tabs are down here. So that's good. This op is done. So we can hide simulation. Now I'm going to come in and I'm going to select every single one of these circles. And to do that, it's actually easier to sort of select everything and then deselect what you don't want to cut. So I'm going to deselect the inside and outside profiles, and we only have the circles left. So with the circles selected, we can click Contour, and we're using the same cutter here, and we're going to go the same depth. And again, I'm going to overcut by about 5 thou. We want to be inside the feature, and you can see that the diameter of the circle is 0.26 inches, and our cutter is 0.25. So there's not a ton of room, which is why there's only a little blue dot representing the toolpath. We don't need any tabs on here. The cutter is actually going to take away all of the material. And I'm going to name this hole pattern, just so I know what it is. And again, we can come down here and simulate, make sure that we're on the right path, and you can see all of our holes there. So that operation's done. Now we want to address this back panel, and the back panel is identical to the center 3 panels, except this center feature, which instead of being a through cut is going to be a pocket. So we're going to click Contour again, and we're going to come down here and say our offset direction is actually pocket, and that changes some of the features over here on the left pane. But the one that we want to look at is this max depth. So the material is 1 inch thick. We're going to cut away 5/8 of an inch, so 0.625 to make a nice clean pocket. And I'm going to name this operation back panel pocket. If I could type, and then click OK. So the last thing we have is the outside profile cuts. These are all the same, so we'll select all 4 of them, click Contour. We're using the same cutter, and we're cutting all the way through this time. So use stock bottom. We'll add another 5 thou just to be safe. But for this operation, we want to cut outside of the line. So you can see now the blue line has been offset to the outside of our feature. And because we're cutting all the way through, we want to add tabs to this design, to this feature. So change the width to 6th and the height to 3, and then we're going to add 4 tabs for each one of these pieces. Then click OK. And we will name this outside profile. And click OK. Now if we hit the simulation button, we can see all 4 of our parts are ready to go. We've got tabs, we've got a pocket over here on the back panel, and all the profile cuts on the other pieces. And now that we have the design done, let's do one last simulation to make sure that we're still on point. And it looks good, except I just realized this back panel, these holes actually have to be a little bit bigger on just the back panel because we'll be putting in threaded inserts. So before we save this out, let's go back into design mode, and we're going to select the circle, and we actually need to ungroup it to access the individual features. So we'll ungroup that, and we'll come into this circle. Instead of a radius of 0.13 inches, the radius on the back panel should be 0.18 inches. So we'll change that, click apply, and you can see the circle grows to the appropriate diameter. So we'll change the next one and apply it, and then get up to these top 2 and change those and change that one, and we're done. And then here's something cool. When you go back into Toolpath, you can see that it kept the inside cut on those circles, and the Toolpath is actually slightly bigger than the other ones because the circle is bigger. So we'll do one more simulation, and now it looks good. So we can hide that, and we're going to do 2 things here. We're going to save the design file by clicking Save at the top, and that's going to allow you to open this back up in the future and edit it without having to redraw everything. It also saves the actual toolpath information, so you can come back in and edit those as well. But after the design file's saved, we need to save the actual G-code. And the G-code is going to be the file that your machine uses to actually cut these parts. So Carbide Create will automatically name design files with the C2D extension, and you can see that up here. And all G-code files will be saved with the NC extension, and it puts that in automatically. So Bluetooth speaker, MDF pieces, and click Save. Now that we have the MDF body designed, it's time to design the front panel or the bezel. So what you can do is open up the MDF pieces that we just designed and save as a different name. So we're going to call this Bluetooth speaker bezel front, because this is actually a 2-sided part. So we're going to do the front and the back as separate files. Save that. And now we want to go into job setup, and we want to change our stock sizes. So we are using a piece of maple that's 16 inches wide by 5 inches tall, and it's planed down to 3/4 of an inch thick. We're going to keep Z0 at the top, and we're going to use the center point as the origin on this one. That's going to make it easier for us to flip the part when it's time to do the backside. So make sure our grid spacing is correct. It is 1/4 of an inch, and we're going to click OK. Now we're just going to delete 3 of these pieces. So I'm going to select them, press function delete, and those go away. Now we can grab the remaining piece, and we're going to rotate it back 90 degrees. So it's going left to right like our material. And we're going to move it to the center. So the front panel has 4 holes in the corner, just like the other pieces, but these are actually countersunk holes. So to do this, we're going to select all 4 of the existing holes. The inside circle is going to remain the same. We're going to select all 4 of these and then use our offset feature. So we're going to say offset those lines outside by 0.067 inches. And now you can see all 4 of those circles are offset. And the other feature the bezel has is 3 circles vertically aligned across the panel, evenly spaced. So I'm going to start with this center circle that has a radius of 1.45 inches. Apply that. And the flanking circles are going to be 1.18 inch radius. So we made one of those. We can select it, just Command C to duplicate it. And then we're going to put it up here for a second, because to get the spacing right, I'm going to draw another rectangle that we'll use as a construction line. So the rectangle width should be 6.8 inches wide, and the height doesn't really matter. So there's our rectangle. Now we can grab our circle, center point, and we can match it up with the midpoint of the rectangle we drew. And now we know that those circles are center to center, 6.8 inches apart. That's the main design of the front of the bezel. So at this point, we should start the toolpath. After we have the design done for the bezel, the front of the bezel, we want to add toolpaths. So we're going to chamfer the insides of these circles, and we're going to chamfer the entire profile of the part. To reduce the number of times we have to change tools, we're actually going to start with the chamfer and then switch to the 1/4 inch end mill. So let's select all 4 of these features, hit contour, and we're going to do no offset for this one. So that means that the center of the cutter is going to be exactly on the center of the line. And for this, we want the depth of cut to be, the max depth to be 0.2 inches, and our starting depth at 0. But we want to change our tool from the 201 to the 301. And again, the 301 is a 90-degree V cutter. These speeds look a little slow to me, at least the plunge rate does. So I'm going to switch the plunge rate to 15, and I'm going to switch the feed rate to 20 inches a minute. This has a depth per pass of 0.225 inches, which is a little aggressive, so I'm going to switch that to 1/8 of an inch and click OK. That'll be a little more conservative, but the job should finish, and we should get a better surface finish on the features. So that looks fine. I'm going to say that this is a chamfer op and click OK. So now that we have the chamfer done, we're actually going to create a new toolpath group, and this is going to be for our 201 cutter. So the 201 we're going to use to cut the inside of these circles all the way through, and we're going to make a couple pockets, and we're going to cut these screw holes all the way through. So let's select all of these. And now we're going to do contour. We're going to switch our cutter here to the 201. And we're going to use stock bottom. I'm going to add 3 thou this time, just to make sure we make it all the way through. And I'm going to say this is an inside cut. And name this Inside Profiles. Then click OK. And we can see in the simulation, switch to MDF. We can see in the simulation what it's going to look like. One limitation of simulation is it doesn't simulate V cutters correctly. So just imagine that there's a draft between this edge and this edge, and that's what your chamfer is going to look like. So we'll close that simulation, and then the last op we have is a profile cut to actually cut the part out of the material. So we'll select this outside rectangle, click contour, use stock bottom, add 3 thou again, and this is going to be on the outside. And you can see that that blue line updated to the outside of the feature. And for this, we're going to want to add tabs. So I'm going to add 2 tabs on each side. And I'm going to make these tabs 6 inches wide, 6 millimeters wide by 3 millimeters tall. Click OK. Call this outside profile. And show simulation. Okay, now we want to save this file again, the design file, and export the G code. And we will keep, before we export the G code, we have to export the separate tools into separate files. So I'm going to start by unselecting group 2, which means that only group 1 will export. So I'm going to say save G code, and I'm going to call this Bezel front 301 to say the name of the cutter, and click save. And then I'm going to uncheck group 1 and recheck group 2 and save this file separately, but save it as 201 so we know which cutter to use. Now we need to do the design for the back side of the bevel. And when we get over to the machine and actually mount the material, I'll show you how to flip the part over. But for now, just trust me that it's going to work. What I did was I opened up the Bluetooth speaker bezel front design file, and I'm going to do another save as, and I'm going to save it as speaker bezel back. Click save. And the only thing we really need to do here is add the squares that are going to be the countersink for the speaker. So I'm going to draw this square. The center square needs to be 3.4 by 3.4 inches. And these side squares need to be 2.88 by 2.88 inches. So there's one, and now we can just duplicate this. Control C, grab the center, and then match it up with the center of this circle. And now we can go in and delete the circles. And we'll actually leave the rest of the features, but we're not going to machine them. The only thing we're going to machine on the back side are these 3 square pockets. So I'm going to go into Toolpath here. I'm going to uncheck our old Toolpaths, and I'm just going to make a new Toolpath group that I will add these pockets into. So I selected all 3 of them. I click Contour. We're using the 201 cutter, and we're going to cut these pockets 0.4 inches deep. I'm going to say it's a pocket. And you can see the preview updated automatically. And we're going to name this bezel rear pockets. Click OK. And as long as we keep these other groups unchecked, we can save the design file, and then we can save the G code. And this is bezel back 201. Click save. Now it's time to set up the material on the machine. Now we're at the machine, and it's time to set up the material. So because this is a 2-sided job, we have to do things a little differently than we normally would. And the first thing we want to do is square up this piece to the front of the machine. This is a low precision flip, so there are actually better ways to do this, but this is a super easy way, and because the backside cutouts don't require super tight positioning, this method will work fine. So we're going to push this up here and just sort of center it on the table. But to find our center point, we're just going to use a straight edge, and we're going to do a little trick here where we draw diagonal lines. And where those 2 lines intersect, that is the center of the material. So if you remember in Carbide Create, when we made this design file, we started the origin from the center point, which is why we're marking the center point on this piece. So we're going to flush it up against the front here, and then we're going to clamp it down. These are top clamps, and the thing you want to remember with top clamps is the back side of the clamp needs to be slightly higher than the front of the clamp. And that's because if you don't make the back higher, then when you clamp the actual screw down, all of the force is going to be in the back of the clamp when we actually want the force in the front of the clamp. So we're going to tighten this guy down. That sounds pretty good. And we'll go over and do these two. And we want this back side a little bit higher than the front side just so the force is going in the right direction. We can move our reference block off to the side. And one more sanity check for this flip. We're actually going to mark these corners. You don't have to mark all of them, but marking 2 corners should give us enough reference that when we flip this over, we can line it back up pretty accurately. So now the material's down, it's clamped in, it's not going anywhere. If you remember the design file, we're actually running this 301 cutter first to minimize our tool changes. The other bonus to running a V cutter for the first op is it's really easy to line up the point of this cutter with our center mark. So you want to make sure that this is nice and tight. Sounds good. Clear off your table. Now it's time to home the machine. Once Carbide Motion is loaded up, you need to connect to the cutter. You'll hear an audible ka-thunk noise. And the first thing we want to do always is click jog, and it's going to want you to initialize the machine, which basically means begin a homing cycle. The homing cycle always works in the same order. The Z-axis will home first. That actually homes to the top of the travel. And then the X and the Y will both seek their home positions, which are in the back right corner, respectively. Once they both find their position, the machine will back off slightly and it'll be ready to run. Okay, the machine's homed, and now we want to jog it to the X that we marked on the material. To get it close, I'm actually going to use the rapid position and then click the center button. And then from here, we're just going to use the keyboard control. So you can use these on-screen buttons, but up, down, left, and right will move the Y and the X axis respectively. And the comma and period button will move the Z-axis down and up. I'm going to change the increment here to fast because we have quite a ways to go. Now I'm going to start jogging the machine until I'm in the vicinity of the X. Now the closer I get, the smaller I want the increment to be. So this is looking pretty close. So I'm going to switch it to 1/10 of a millimeter now. And you can see that it's just tiny movements. So now we're going to start lowering it down. I like to spin the cutter a little bit. And then I know exactly when it's engaged with the material. Okay, so now we are dead center on the X. The machine is in the starting position. But the thing that you have to remember is once you get it into position, you actually need to set the 0. And this is what we call job 0. So you click set 0 in Carbide Motion and then 0 all. So that sets everything to 0, and that's where the job is actually going to run from. Now I like to move the Z up off the material once it's zeroed. That way when we start up the router, it won't burn the center point. So at this point, we're ready to go. We just need to load the G-code file that we saved from Carbide Motion and run it. So this file is called Bluetooth Speaker Bezel Front 301. Really rolls off the tongue. So we're going to load that. It's going to confirm the name of the file and then the max extents for each axis of travel. Then we need to click Run. And at this point, once we click Start, the Z-axis will come up and tell us to load the appropriate cutter, which we already have loaded. So we'll click Start. This window comes up and says load a 301, which we have. So all I'm going to do is turn the router on. Then it's time to run the job. Now the first operation is done, so we need to do a tool change. Just going to drop this 301 cutter out and use this 201, which is a 1/4 inch 3-flute square end mill. The thing you want to remember clamping in a new tool is you don't want to clamp onto the flutes, but you want as little of the cutter hanging out as possible. Now that the tool's changed, we can use one of these built-in features in Carbide Motion to go back to the 0 point. To do that, you click on the jog button and then rapid position. And current offset XY will take the gantry right back to the last place you zeroed it. So now we don't have to worry about zeroing XY, but we still need to manually zero the Z-axis again, because the amount of tool that's sticking out could have, and probably did, change from the last tool. So here we can use the same method where we slowly lower the cutter until we get close enough. And then you can start turning the cutter. And as soon as it catches, that is Z0. You could also use a piece of paper. So again, you have to click Set 0 in Carbide Motion and then click the 0 Z button. No need to zero the X and Y, they're already set. Done. And again, I'll raise the cutter up just a little bit so when we turn the router on, it doesn't burn that part of the material. Now we need to load our new file. So we go back to the info load screen, click load new file, and this one is called Bluetooth speaker bezel front 201. I'm going to open that up, and we can go to run and start. It's going to prompt us for the correct tool, which we have in, so we're going to start the router. Now that the front side of the bezel is done, we're going to undo these clamps and then flip it over. Here's the thing when you're flipping these parts, you don't want to flip it this way. We want to flip it this way. Also, make sure there isn't none of these chips fall underneath of it because we want it to be flat. Now we're going to do our best to line up these edges with the marks that we made during the last cut. And like I said, this is a pretty low precision flip, so you don't have to be exact, but you do want to get it as close as you can. So this corner looks good. I'm going to start here. Now that we have the piece flipped over, we have to load the G-code file to cut the pockets on the back of this bezel. We name that Bluetooth speaker bezel back 201. So I'm going to open that. And because the material is the same thickness and it is hopefully flipped correctly, we don't need to re-zero. For a sanity check, you can go to rapid position, current offset. and bring everything back to the 0 point. Looks about right. So we can click done there, and now we just need to run the job. Now that the piece is cut out both sides, all we need to do is remove the tabs, and there's a bunch of different ways to do this. A multi-tool, a flush cut saw, pliers. You'll probably want to kiss the sides against a belt sander or just to clean them up, but we just need to get this out of the stock material now. We have our piece of MDF mounted. Again, this is 12 inches by 24 inches by 1 inch thick, and we're using top clamps. So a couple things to remember with clamping, always. The back end of the clamp has to be slightly higher than the front end of the clamp. If it's not, then all of the downward pressure is actually going towards the back, which we don't want because the material could slide out of place. So all of these are slightly higher in the back than they are in the front. We're going to use the probe to find the 0 point on this part. And if you remember from Carbide Create, the 0 point is the lower left-hand corner. So let's connect to the machine, home it, and then start probing. Connect to the cutter, click jog, and then home the machine. Okay, now that the machine is homed, we can use the rapid position grid to get close to the lower left-hand corner by clicking on the southwest coordinate. So that's pretty close. Let's move our increment up to fast, and then we're going to roughly jog over close to the corner here. Okay, now it's time to use the probe. So the probe has a relief cut on the bottom that has a square corner that we're going to line up with the corner of the material. This is the ground clip, and before we actually probe, we want to make sure that when you touch the ground clip to the probe, the LED turns from green to red. That means that the circuit is active and we won't drive the cutter into the probe. So that looks like it works. Now we just clip this onto the end mill, and we go back to Carbide Motion, click on Probe, and then we're going to do the probe type, which for this case we're going to find the corner and the top in the same movement. So we're going to do probe corner Z, X, Y. We're going to select the tool that we have in the collet right now, which is a 1/4 inch square end mill, and then we just click Begin Probing. But before you click Begin Probing, you need to make sure that the cutter is within about 1/2 inch of this circle on top of the probe. That's our target. So now that that's ready, we click Begin Probing. And the cycle just found the Z-axis 0. Now it found X 0. And it'll go to the front of the probe to find Y 0. Okay, probing cycle is complete. You need to remember to remove the clip. If you don't, bad things will happen. And slide the probe out of the way and off to the side. Now that we're all zeroed out, we can exit the jog menu and go back to the load info screen and load the file we just made in Carbide Create. The name of this file is Bluetooth speaker mdfpieces.nc. Open that up, and we can go to the run screen. and run the job. Okay, that job just finished. Now we're going to take this material off the table, cut the tabs away, and then glue these pieces up and wait for them to dry. All right, we have the parts out of the machine and we cut the tabs away. Now we're going to glue up the back piece and the 3 body pieces. We're going to put them in the vise and let them dry. Just want to make sure that you get a pretty even coat of glue on all of the pieces. You don't have to work super fast here, but you don't want to dilly-dally either. So spread these out. We're going to get a bunch of squeeze out once we clamp these together. So you don't really want to overdo it, but you need enough. Basically, don't put on too much and don't put on not enough. You could use a brush or a roller, one of those silicone brushes. Might make this a little less messy. Okay, we got our 3 pieces stacked here, and the only thing we want to keep in mind is we really want these edges to be as close to flush as we can get them. Looks like these are pretty good. I'm going to take these over to the vise and clamp them up and let them dry. Okay, the glue up is done, the glue's dried, and went ahead and sanded down the edges of this so they're nice and flush. All the glue's gone, and it's ready to take a coat of shellac. We're actually using a primer shellac combo. So I'm going to pop this open and we're just going to apply it with a roller. So it's just a regular foam roller, nothing special. We want to make sure that we hit all of these edges. We want to make sure we hit all of the faces. We're going to come back afterwards and Plastidip this whole thing. And if we don't shellac it first, the MDF is going to act like a sponge and it's going to suck the Plastidip in and it's going to look like garbage. So just be sure that you prime everything you can see. Okay, the primer is on all the faces here. I'm actually going to use these 2 pieces of scrap wood to support the inside of this box, so none of the painted faces are touching the table. If you're a woodworker, you probably have some standoffs or a nail board, but this will work just fine. So once this dries, we're going to come back and Plastidip the whole thing, and then we'll move on to final assembly, and we'll get to hear this thing in action. Okay, now the primer is dry on this MDF body. We're going to put these threaded inserts in. These are 1/4 20-inch. And then we're going to put some screws into the inserts just to protect the threads, because when we're done with this, we're going to go outside and Plastidip this whole body. So these threaded inserts go in with just an Allen key. And the thing you want to keep in mind is you really want to keep them straight when you start them. Once you start them straight, then they'll go in straight, but if you start them crooked, you're going to end up with problems. They're going to look ugly. We're putting these inserts in because when the bezel goes on the front, there are going to be 4 long screws that will connect to these inserts and pull the whole thing together. If you have a countersink bit, you could hit the back of these holes lightly, and that would let you get these inserts in a little bit cleaner. Okay, now the inserts are in. I'm just going to slide these screws in here so the holes don't get Plastidip on them. All right, so this is the Plastidip. It's spray application. And the thing you want to remember with this is less is more. So we're going to do multiple coats, 5 or 6 coats of this, The first coat, you're going to spray it on super light, and you're still going to be able to see the primer and shellac through it. Wait for that to dry, put another coat on. You might still see a little bit of white coming through. Wait for that to dry, and then just slowly go through it until you've built up enough that you've got a nice consistent coat across the whole body, and there is no primer showing through. And you want to wait about 15 minutes between each coat before applying the next coat. So this thing's all ready to go. We're going to take it outside, spray it, wait for it to dry, and then finish up with final assembly. We're going to put the electronics together. We have to solder a couple of things, just the speakers actually, and mount the board into the carrier tray, but otherwise we're just going to be plugging cables in. So we'll start by mounting the board, and these are just tiny Phillips screws. And there are standoffs on the board itself that line up with the holes on the PCB. And the carrier board is symmetrical, so it doesn't matter which way you orient this board. So I like to get all the screws started before I crank them down. And these are really tiny. Just drop them into the holes. So we have the main PCB mounted on the carrier. We're going to put this, this DC barrel plug jack in, and you can reference the wiring diagram that comes with this to know that this actually plugs in right here. And this connector is different than the rest of them, so you can't really mess this one up. I pre-soldered the wires on this before we actually put it on. There's a little bit of heat shrink tubing over it to protect it from shorting. And the next thing we're going to put on is the volume control. Some of these wires are pretty long. You could, if you were really up for it, you could cut these down and splice them back together to get sort of the perfect length. But there's enough room inside of the box that we shouldn't have to do any of these. These connectors are also polarized, so you can't put them in backwards. Or you can, but it would be really difficult. So if they don't just go right in, you're not doing it right. And again, the volume control is number 4 on the wiring diagram, which is at the very top of this board. So put this in. So that's done. This is the on-off switch. Again, I pre-soldered these wires, put a little bit of heat shrink tubing over them. So this should be good. And the power switch is number 6, which is over here on the right-hand side. It should just pop in. There we go. Okay, now we're going to do the soldering. These are a couple things to note here. On the wiring diagram from Dayton Audio, they actually have 2 of the connectors reversed. There's a 4-pin connector at the bottom of the board that connects both the right and left speaker. So the wiring diagram is incorrect. The right is actually reversed. So what shows negative is actually positive. We'll have notes for this, but just remember that the wiring diagram is incorrect. So this is the 4-pin connector, and you can map out pins 1 and 3 connect to the right speaker. So I have those 2 wires here, and there is a positive and negative lead. So what I'm going to do is put these wires in, and then I'm going to use a little piece of tape, and I'm going to hold the wires down as a third hand. So the soldering iron's ready to go. We just need a little bit of solder. You want to make sure you've got a good connection here. The better your connection, the better the sound is going to be. That one's pretty good. it's perfect. We just finished up the right speaker. Now we're going to do the same thing to the left. And again, this does have a positive and negative. So you're going to want to make sure you get those right. And we're going to do this the same way by putting these wires in and then taping them back. All of these wires came pre-tinned, so you don't have to worry about stripping them back. All right, that looks good. We're all wired up. Can take our tape off. This 4-pin connector goes right into the back of the board here. So those are ready to go. This is a passive radiator. Looks like a speaker, but there's no wiring. Okay, so now it's time to connect the battery charging circuit. And this carrier holds 3 18650 batteries. They're pretty easy to find. We actually salvaged our batteries out of an old laptop battery. So if you want to get thrifty, you can do that, or you can just buy them on the internet. So this carrier board has 3 identical connectors, presumably to daisy chain several of these together, but you can pick any of them to plug this wire into. I'm just going to pick the one here on the back, or on the left. So that's connected, and then if we look at the wiring diagram, this is going to go on the right-hand side in this top beige connector. Now, this sort of goes without saying, but these batteries are polarized and it matters which way you put them in. So an easy way to test what's positive and what's negative is just use a regular multimeter and measure the voltage. These are 3.7 volt. So what you can do is just put the leads on the end here, and it shows 4.06 volts, and there isn't a negative symbol. So that means that where my red probe is the positive end, and the other one is obviously the negative end. So you could write on these with Sharpie if you wanted to, but I'm going to go ahead and just put them into the carrier as we go. They should all be the same, but I'm going to check them anyway. So now that we have the battery in, we can actually test this entire circuit before we start putting it into the box itself. And to do that, the first time that you turn it on, and probably to charge your batteries anyway, you need to plug in the AC power adapter. And this is a 19 volt power supply, 19 volt, 2 amp AC to DC power supply. So we've got that plugged in. It looks like all of our wiring is correct. Now we just need to flip this toggle switch, and you'll see a couple of blue lights on the board start flashing. That means that it's in pairing mode. So I'm just going to go ahead and connect. All right, we're connected. Now we can play a song. All right, sounds like everything worked just fine. Now we're going to unplug this and then put everything into the enclosure. While the Plastidip dries, the final coat of Plastidip, we're going to mount the speakers into the bezel. So we're going to need a couple of things. We have 1/4-inch length pan screws. I think that these are number 6 1/4-inch length pan screws, and number 6 3/4-inch length pan screws. So the longer screws are going to be for the passive radiator, and the shorter ones are going to screw our speakers into the bezel. So what we want to do is actually mark these holes first, because we need a pilot hole so we don't split the wood. And what I did was just took a regular drill bit and put a piece of tape about 1/4 of an inch from the tip, just to let me know not to go too deep so I don't put it through the front of the bezel. So I'm gonna lay these speakers down and just mark them out with a pen, remove the speakers, and then drill the pilot holes. So one of the things you wanna do when you're doing this is make sure that your speaker's lined up with the front of the bezel. You can just take a look at the front, see it centered, hold it in there, and then mark the holes. We'll do the same with the other side. For the radiator, because the connection point is actually stood off from the face, we're going to use one of these screws to mark the hole. Okay, we have all the holes marked. Let's go ahead and drill these. Okay, all the pilot holes are drilled. Now we just have to actually screw the speakers in. So same thing as before, we're going to want to line these up. Just make sure they're centered. And for this, I'm actually going to put these screws in by hand because I don't want to strip these holes out. All right, now the bezel's done. Speakers are mounted, passive radiator's mounted. They're all soldered up. Let's move on to final assembly. Okay, we have all the components mounted into the back of the enclosure. You can see here that we just used those same 3/4 inch screws to keep the battery pack in, and the smaller screws, those 1/4 inch pan heads to keep in the carrier board for the actual Bluetooth amp. That's all in. Now we just need to attach the bezel to the front of the speaker after we plug in the actual speaker plug. So you can see this looks a little bit different than when we mounted the speakers because I finished it with just some beeswax, which gives it a nice little sheen and changed the color, darkened it up just a little bit. So let's connect the speaker. That's in. And we're almost done. Line these edges up. And these are 4-inch 1/4 20 socket head cap screws. These are what attach to the threaded inserts in the back of the speaker. So when you're tightening these socket head cap screws down, you want to make sure that your sides are lined up. It should be pretty tight because the dimensions are all the same, but the holes are slightly oversized. So just pay attention to the edges. And that is a Bluetooth speaker.